Today's curiosity is assisted by Hired Hand Brown Ale from Heritage Farms Brewing Company. They describe it as a medium-bodied English brown ale with moderate sweetness and balanced bitterness. Should have some notes of toffee and chocolate and a bit of caramel. In addition to the usual beer ingredients, there's a bit of wheat in this one as well, which should lighten it up a little bit. Yeah, for a darker ale, that's a pretty nice, light, summery sort of a taste. I like it. So today, I'm going to be looking a little bit closer at this network cable tester that I got in the last mailbag. I'm curious to see how it does its little magic. It's stepping along, sending a signal down each of the conductors on the cable, but I'm assuming that it must be using the other cables as a return path or something. Otherwise, how would it tell if there are broken cables and stuff? Because it needs some sort of return path, right? According to the manual, such as it is, it needs to have at least two conductors functioning for the tester to work. There's pretty bad English in here, but yeah, if less than two cables are connected, then none of the lights are on. But it doesn't seem to matter which ones it is. So yeah, that confuses me, and that makes me want to look into this thing a little bit closer. So I guess first, I don't see any screw holes, so I assume it's probably clipped together. I'm guessing. I'll have to find out here. I would hope that it's got screws, but I don't see any screw holes in the thing anywhere. There is a bit of a dividing gap here, so let's see what happens. Well, it looks like there is something in the middle holding it. I can pry on both edges, and both edges will come up, but the middle's not coming up. So, have they hidden some screws underneath this label? Oh yeah, can you see little divots there? There's some, yeah, I can feel one there, and I can feel one up there. Okay, so I hope I don't mangle this this sticker too badly by peeling it up. Yeah, it's just a paper sticker. Damn it. I'm going to destroy it. I don't want to. Oh yeah, there you can see the screw holes. So maybe if I just peel this back a little bit, I can get at those. And then I'll use double-sided tape or something to stick it down to put it back together. Let's try that. Now let's see if it wants to, oh yeah, easily. Okay. There's just one fairly simple looking circuit board in there. It looks like it's just sitting on those pillars. All right. So we have the connectors over here, the 6-pin RJ12, which also does RJ11, and the 8-pin RJ45. We have the LEDs, and it looks like each one is connected to one pin here, I think, except for that one, which is the shield ground, and that is connected to the shield ground. Okay. 3 little MILF diodes there, a couple of transistors, the LED which flashes with the pulse of the thing, so that flashes with each pulse that goes down the line here. Handful of resistors, couple of 3-pin devices, and of course the main chip. 2 little 3-pin devices are labeled 1AM. So a 3-pin SOT23 device with the 1AM marking on it seems to be an NPN transistor. And the main chip is a 4017. Okay. Of course, the 4017 is a decade counter. That one we have seen many, many times before. It is one of, if you can have a favorite chip, this is one of my favorites alongside of the 555. It is a very simple circuit. It's an easy way of making stepped outputs or chase lights or things like that. Pin 14 is the clock input. All right. Which is that one there. So it's getting its clock from up here. And I've already measured it out. It comes from one side of this LED, which makes sense because that blinks with the clock. And then that comes from the collector of this transistor. And those two transistors are tied together. So that is our oscillator. and the switch will be changing either while turning the circuit on, but also switching in different values of these resistors into this oscillator to change the speed of it. Because if you remember from my demonstration of the mailbag, that switch gives us two different speeds. And I'm guessing that capacitor is the timing capacitor for that little oscillator circuit. So then these three diodes are connected to three of the outputs on the chip, and they go to three of the pins on both of the connectors. So I'm guessing that that has something to do with how we get our return path back from the other end, but I don't know yet until I fully reverse engineer this and look at the other half of the circuit here, which I'm going to guess also has some hidden screws underneath there. Yeah, just two of them. I think instead of ripping the sticker completely apart, I'm just going to do it this way. Yes, I'll leave the screw holes visible, but so what? And that just comes apart like that. So what is going on here? Nice and simple. We just have the matching row of LEDs. We have two little diodes there, and oh, that's a third diode. Okay, so I'm guessing that those three diodes work alongside these three diodes here to steer current and give us our return path, our low voltage or circuit zero voltage or whatever it is, to allow these LEDs to light up and get current down the other conductors. But now is the time where I pause the video for a while. I grab my notebook and my magnifying glass and my meter and my drink and draw this out. And for you guys, it'll just be a snap of the fingers, but for me, this could take a little while, but I'll get this drawn out and I'll be back. All right, I think I got it figured out here. It took a little bit longer than I thought because, of course, surface mount and traces disappearing underneath other things, but me and my trusty multimeter and my magnifying glass, I think we got it here. Let's start with the remote because that's the easy one. So the RJ45 and the RJ11 are connected in parallel, at least the first 6 pins of the RJ11, and they are all connected to the anode side of all these LEDs. Individually, the cathode side of all these LEDs is connected to a common bus here. So we have LEDs 1 through 8 and the shield ground. And then that common goes through three little MELF diodes, 1, 2, 3, which also go back to pin 1 and pin 3 and pin 4. So at any given time, only one pin is pulled high. The rest of them are pulled low. So that gives us a path through these diodes to back to the master unit. So it's only getting a return path or common path, whatever you want to call it, on 3 pins. So as long as one of those 3 pins is working, then this will work. And then the slightly more complex board on this side. I could have drawn this a little bit neater or redrawn it, but I chose not to. So we have the 9-volt battery. We have one side of the switch just turning power on to the circuit. It goes through a diode just for polarity protection. Goes to the positive voltage pin on the 417 and also jumps over here to this point in the circuit here, which provides power down to the rest of it through either that 20K or this 1K to the clocking LED. And that clock LED is connected directly to the clock input of the 417. So when that goes low, the LED goes on. Fine, that's all good and normal. Then we have the 2 transistors here connected up as an oscillator. That capacitor along with that resistor and this resistor, and that one in series, I guess, but mostly these 2 resistors and the capacitor are the timing elements for this little oscillator here. The other position on the switch to go between high speed and low speed just shorts out this 430K resistor, takes it right out of the circuit. So when you're in slow mode, that is in series. When you're not in slow mode or in the faster mode, then that 220 just goes up to here and finds its path back to power. Now then, the LEDs down here, I've got them drawn out in an order that makes sense just to draw them on the schematic, because they don't come off the 4017 all completely in order. But there's pin 1, 2, 3, 4, 5, 6, 7. Where's 8? Why didn't I draw 8? It's in here somewhere. I didn't draw 8. Doesn't matter. Let's just assume it's there. It's coming off one of these pins here. Probably pin 11, because that's the only one left. Let me just break in here from editing. I noticed a couple of mistakes, and I want to catch them before you guys bust me on it in the comments. First, those two emitters on those two transistors, there should be a ground connection there. I just didn't notice it initially because it's hiding underneath the chip. And the other thing, the number 8 pin is actually one of those two that's labeled as number 6. I just, for some reason, labeled them both as number 6, but the one of those is actually the number 8, so it's not coming off pin 10 or 11. Right, back to the video. And so those step through, because that's what the 4017 does. When it's being clocked, it just brings each of its outputs high, and when they're not selected, then they're pulled low. So that provides a 9-volt source through the LED on this side of the board. These LEDs here, which I didn't draw as LEDs, but these ones are all LEDs. Just fine. There, they're LEDs. So those all go through there, out to the connector, across to the remote, and so you have this LED in series with the LED on the remote. Now then, for the reverse path, we have 3 MILF diodes again. There's the one that goes to pin 1, to pin 3, and to pin 4. Same as on the other side, except for this time they are going in the opposite direction because they are connecting the low voltage side of this through to the remote unit. So as long as you have either pin 1 or pin 3 or pin 4 functioning, then this whole thing will function. Allow me to demonstrate. So here we've got a Cat6 shielded cable connected, and you can see that all 8 pins are lighting up, plus the ground. So then if I've got a cable that's missing a few pins, and I cut all of those pins that have the diodes on them, there we go, it stops working. So we've got still, 5 wires intact here, but the 3 critical ones aren't working. So I guess if it's showing you nothing, then you've got a good chunk of the cable missing, but otherwise it can figure it out pretty effectively. I'll just reconnect that. There we go. It kind of works. There we go. Yeah, so that's a kind of a neat circuit. Surprisingly simple too. I thought it would be a microcontroller or something else like that, but this is a really old school circuit. I like it. And now the question is, can I get it back together? Well, it shouldn't be that difficult. It was just 4-6 screws. The hard part is going to be getting that guy back on. That's kind of a cheesy way to do it. There's no windows or anything in the paper. It's just assuming that the white base of the paper is translucent enough to see that through there. But anyways, I will throw this back together. Shouldn't take but a minute or two, and I guess come back for the conclusion. There. That was actually the hardest part of putting this thing back together, was getting the sticker on there. I ended up using some double-sided tape, but it was a real bear to get the backer separated from it. Anyway, that is working again, or at least it appears to be. Let me just give it a quick test here. Yep, definitely working. Cool. Oh, I am happy with that. I know more than I did a few minutes ago, and it still works. Oh, good. Hope you guys enjoyed that. Found it interesting, informative, entertaining, amusing, frustrating, something, some way. Anyway, yeah, thanks for watching. Questions, comments down below as usual. I have a link to this thing down below as well if you're interested in picking up a cheap little tester. Thanks for watching. I'll talk to you later.